Welcome to The Explainer. Today we're doing something really pretty fascinating. We're taking a highly technical, rigidly structured Russian aviation manual, and we're totally transforming it into a captivating, anatomical tour of an absolute engineering marvel. We are going to look at the anatomy of an aircraft, not just as a machine, but as a living system of rules, structures, and meticulously designed skin.
Just look at that sleek silhouette. That's the Yak-40. And here's the wild part. Just to safely operate and maintain this single machine, it requires a staggering 10 strict volumes of documentation. It's an incredibly complex organism, and to keep it safely up in the sky, every single minute detail has to be documented, understood, and perfectly executed.
Now, out of those 10 massive volumes, we're going to hyper-focus our teardown right on Book 2. This specific manual covers the whole airframe, the crew and passenger cabins, and all the essential survival and sanitary equipment. Basically, we're going to open up the very structural core of this machine.
All right, here's our blueprint for today. First, we'll hit documentation and safety. Second, the anatomy of the fuselage. Third, the load-bearing frames. And finally, skin and access. Let's jump in. Section 1, documentation and safety. Basically, the DNA of aviation protocol.
So, before anyone even touches the metal, we've got to understand the rules. In the original manuals, this rigorous 10-book system separates every single concept logically. Book 2? Well, that's dedicated entirely to the physical airframe, the tangible body of the aircraft itself. And what's truly profound here is the human gravity introduced right in Chapter 0. It explicitly states that maintenance personnel bear personal responsibility for knowing the instructions and all the active amendments. You know, maintenance in aviation, it isn't just a simple task or a checklist. It's literally a life-or-death responsibility carried right on the shoulders of the crew.
So how exactly do they guarantee everyone has the absolute safest, most up-to-date info? Well, they use this brilliant physical tracking system. Every single update has to be logged on a registration sheet. Standard text changes? Those are instantly identifiable by vertical black lines in the margins. But get this, for urgent, temporary changes, they're printed on these distinct bright yellow pages. It's this beautifully simple, highly visual system so mechanics absolutely never miss a life-saving update.
Moving right along to Section 2, Anatomy of the Fuselage. Engineering the core.
Okay, so the manual uses a really specific term for the Yak-40's design, semi-monocoque. Now, what does that actually mean? Basically, the aircraft isn't just some heavy frame with loose skin draped over it. Instead, it's a completely all-metal framework where longitudinal stringers, transverse frames, and the outer skin itself all work together to share those intense structural stresses of flight. The skin actually carries a massive chunk of a load.
To give you a quick sense of scale, the main circular diameter of this fuselage is exactly 2.4 meters. It holds this perfect circle right through the passenger section, and then it brilliantly transitions into this sleek elliptical shape as it tapers towards the tail.
And within that 2.4-meter tube, life support is strictly divided. You've got the pressurized zone, the safe environment for human life that houses the cockpit and passengers. That spans from frame 2 all the way to frame 33. It's meticulously sealed from the inside with U-20A sealant, and then on the surface with U-Zomes 5 and UT-32. Contrast that with the unpressurized zones, like the nose cone, the tail, and the wheel wells. Those are left totally raw and completely exposed to the harsh, freezing atmospheric changes of high altitude.
Section 3. Load-bearing frames. The skeleton.
The raw numbers making up this complex skeleton are honestly wild. The fuselage relies on 50 total transverse frames, which is what gives it that circular shape. Intersecting those are 62 longitudinal stringers running lengthwise, and these stringers remain largely unbroken along the whole length of the plane, only stopping for major cutouts like doors or wing attachments.
Let's take a quick spatial journey down the length of the aircraft and stop at the most critical bones in the body. Right at the very front, Frame 1 holds the nose cone and weather radar. Moving back a bit, Frame 8 acts as the rigid partition between the crew and all the unpressurized equipment. Then we hit a massive shift in purpose dead in the center. Frames 24 through 28 do the absolute heavy lifting of mounting the massive wings. And finally, Frame 33 seals off the passenger cabin right at the tail.
Now, right in the middle of the aircraft, that's where the heavy-duty engineering really takes over. Frames 24, 26, and 28 are the ultimate powerhouses connecting the wings to the fuselage. Because they have to carry the entire weight of the aircraft during flight, they are built thick from stamped duralumin, which is a specialized, super lightweight aerospace alloy.
and they're bolted together with milled plates. Frame 26 actually has a highly specialized job. It takes the massive outward pressure pushing against the pressurized passenger floor and safely transfers all those forces directly into the main spars of the wings. It's incredible.
Moving to the back, we arrive at frame 33. This frame is a true multitasker. It serves a vital dual purpose. It's the final, ultimate rear barrier locking in the pressurized oxygen for the passengers. But simultaneously, it contains the heavy-duty mounting points that anchor those massive, powerful side engines right to the fuselage. So it is the exact point where human life support meets extreme mechanical thrust. All right, our final stretch. Section 4, skin and access, the outer shell. So the duralumin skin that wraps the whole skeleton, it actually isn't applied the exact same way everywhere. In the highly stressed, pressurized midsection between frames 8 and 33, the skin is actually welded, and then it's reinforced by injecting VK1-MS adhesive directly into those weld seams. This adds immense strength and totally blocks corrosion. But out at the non-pressurized extremities, like the nose, the tail, and the areas over the wings, they rely on traditional countersunk rivets. It's a brilliant, highly targeted engineering choice.
Now, the crucial point in aviation is always weight, right? To shave off vital ounces, the manual details a truly surprising process called chemical milling. It feels almost counterintuitive, but on the inside of the skin panels, exactly in the empty square spaces between the stringers and frames, they chemically dissolve away layers of the metal. This makes the skin incredibly thin and light where it doesn't need to be thick, but it never, ever sacrifices the structural integrity of the overall panel. How cool is that?
But of course, a plane isn't just a sealed tomb. Mechanics need to be able to reach the internal organs, so the skin acts as an interface between the human workers and the machine via all these hidden access hatches. You've got battery hatches right up front at frames 1 and 2. Air conditioning valves run underneath from frames 8 all the way to 22. There are even special hermetic drains at frames 10 and 23 just to let out condensation water that naturally pools in the belly. And at the very back, massive underbelly hatches let mechanics get straight into the middle engine cavity.
And to make sure this whole giant shape slices cleanly through the air, we have the fairings. Think of fairings kind of like the tendons connecting muscle to bone. It's a skeletal framework covered by smooth duralumin sheets that seamlessly blends that sharp 90-degree corner where the round fuselage meets the flat wing. This elegant transition is absolutely critical to eliminate any dangerous aerodynamic drag.
So our teardown of the fuselage brings everything into focus. We've really unpacked the incredible spatial logic of this machine today. We've gone from the vital, strict administrative rules of Book 2, right through the semi-monocoque skeleton with its 50 frames, all the way out to the chemically milled skin. I want to leave you with a final thought to take away from this explainer today. Think about the strict tracking of those yellow temporary pages we talked about. And then think about the absolute physical rigidity of Frame 26 perfectly transferring pressure to the wings. How does the rigid discipline of a written engineering manual perfectly mirror the physical structural integrity that keeps an aircraft safely in the sky? The rules of the structure, and the structure is the rules.